Section 5.4, we are going to start 5.4 today. We are not going to finish it today. We're going to start 5.4. You're going to do a lesson quiz on 5.3. So 5.4 is about dividing polynomials. Okay? Not difficult, but you have to follow the steps appropriately. If you don't follow the steps appropriately, you're never going to make it. There's a lot of work involved for every problem. A lot of work involved for every problem. We're going to start with long division. And the long division that we do with polynomials is just like the long division you do with arithmetic. The stuff you learned in the 5th grade. We're doing the same thing here. Same concept, same algorithm. How many times does this go into that? Multiply the two, subtract, bring it down, do it again until you get to what's left over, then you have your remainder. Same process. Okay, then we're going to do, tomorrow we're going to do synthetic division. It's a simplified version for long division. However, you cannot use it every time. You can only use it when you're dividing by x plus or minus some number. If you have like 2x or 3x, doesn't work. It has to be x plus or minus some number to do synthetic division. So that's why it has when dividing by 2x plus 1 or 3x minus 2, you must use long division. Actually, technically, you can use synthetic division for that, but nobody ever teaches that because it's really freaking hard. Really hard. And nobody wants to do it, including me. I don't even know if I can remember how to do it. When dividing by x plus 3 or x minus 4, you can use either method, although synthetic division is easiest. On the test, I don't know if I asked for one or the other in particular. I do believe it says use synthetic division. I don't know if it says use long division. But there is definitely a problem that you have to use long division on, and the one that you can use synthetic division on. Okay? So there is definitely at least one that you have to use long division, that synthetic division will not work. And there is one that synthetic division is doable. I do not remember if I say you have to use one or the other off the top of my head. But it's kind of obvious if you know what you're doing, which one you're going to use. Okay, and this is another one where I grade the test. I can tell who was paying attention and who was not, just by the form that they try to use. Okay. So, like I said, we're going to start with long division today. Give myself a little room. Okay, so the first thing is, we just like regular division, we have our divisor and our divisee, or however, I don't even remember, dividend. That's it. And we just want to try to get the answer out of it. How many times does y plus 5 go into 4y squared plus 23y minus 16? Same idea, just like regular long division. Okay. First thing is I have to check what's underneath the divisor. Is it in standard form? And do I have every power represented from the highest one down? So I have y to the first, y squared, y to the first, and then no y at all. If I was missing a y to the first, let's say 23y wasn't there, and I just had 4y squared minus 16, I would have to put a space in there for that extra y squared. Every power from the highest one down has to be represented. I don't have a problem on either one of these two. If I do, I just have to add a 0 in there to take the space, and we'll show you that when that comes up. Okay. So when you're doing your long division, I am concerned with how many times this goes into each term. The 5 is along for the ride. The 5 has no point in my decision making. How many times does y go into 4y squared? I don't give a hoot about the 5 when I'm making my decision. It's just along for the ride afterwards. So the first thing I do is how many times does y go into 4y squared? What times y gives me 4y squared? 4y. Okay. So 4y times y Notice I write it over where I have the same powers. Okay. So 4y, now it's just like long division. I take this times what's in front, write it underneath, and then subtract. 4y times y, 4y squared. 4y times 5 gives me 20y. That's the only time the 5 comes into play, is when I'm setting this up. And now what do? I subtract. 4y squared minus 4y squared, no more y squared. This better drop out. This first item needs to disappear. If it doesn't disappear, you did something wrong. Okay. 23y minus 20y gives me 3y. Now, when you did long division and you multiplied like this, your next step was to bring the next number down. Bring down the minus 16. And then I do it all over again. How many times does y go into 3y? What times y gives me 3y? 3. So I have plus 3. Now I do 3 times y plus 5. 3 times y, 3y. 3 times 5 is 15. And then what do? I subtract. 3y minus 3y, no more y's. 16, negative 16 minus 15. What's negative 16 minus 15? Negative 31. Good. Okay. I have nothing else to bring down. This would be my remainder. So my final answer, and I have two choices for my final answer. Kind of depends upon what I'm doing. 4y plus 3 with a remainder of negative 31. There is one choice for my answer. Okay, there's one answer. The other one would be 4y plus 3 minus 21 over y plus 5. I kind of prefer the second one, but I'll take the first one. The reason I prefer the second one is because if I'm going to continue doing work, that's what I need. If I'm going to do more to this problem, if this was just a step along the way rather than my final answer, this is what I want. Yes? Sorry, 31. My bad. 31. My bad. 31. My bad. My bad. My bad. Sorry, 31. My bad. Thank you. But yeah, if I'm going to continue working, this is what I need is this one here. Depends upon what I'm doing. If this is a problem unto itself, if this is the end of my work, then hey, give me the remainder to negative 31. Give me the answer and the remainder of negative 31. You're okay. And that's pretty much going to happen in here. But if you were to continue on, this is what you're going to need to work with. Okay, we don't do that in here, but this is a process, a step that in later classes you may continue working with. Okay? So like I said, either one of these answers, I'm good with. Okay, let's do it again. So once again, all I care about for my decision making is what's in front. In this case, the 3x. That's the only thing that isn't part of my decision making. The minus 1 is just along for the ride. It has no process in my decision making. It's just along for the ride. So what times 3x gives me 3x squared? X. And now I multiply. X times 3x, 3x squared, x times minus 1, minus x. That's where the minus 1 comes in. It's there. It's not part of the decision making. It's just along for the ride. And then I subtract. 3x squared minus 3x squared. X squareds go away. 11x minus negative x. What's 11 minus 1? What's 11 minus negative 1? 12. So I have 12x. And then bring down the minus 10. How many times does 3x go into 12x? What times 3x gives me 12x? 4. So I have plus 4. So that gives me, multiply times 4. So that gives me 12x minus 4. And then I subtract negative 10 minus negative 4. That's negative 6. So my answer is x plus 4 with a remainder of negative 6. Okay, you with me so far? It's more tedious than difficult, but you do have some decisions to make along the way. Okay, you do have some decisions to make along the way. Okay. Notice a couple of things. In my answer, notice my answer is lined up with the problem underneath. The powers are the same. If I have a squared in there or a cubed in there, it will line up as well. Don't line it up over the first one, line it up over the second one. Line it up over what the power is, what I'm multiplying. Keep them in line that way. You want to keep it neat and organized. One of the biggest problems I see students do is be sloppy. If you're sloppy with this, you're going to get lost in a hurry. Okay, a little bit bigger problem. 2v cubed minus 7v squared, 10v and 5. So I check, first thing I want to do is check what I'm dividing into. 3, 2, 1, 0. Yeah, I'm good on my powers. Same process. 2v goes into 2v cubed. How many times? What times 2v gives me 2v cubed? V squared. V squared times 2v is 2v cubed. V squared times 1 is plus v squared. And then I subtract. 2v cubed minus 2v cubed is 0. Negative 7v squared minus v squared gives me negative 8v squared. And then bring down my minus 10v. And then once again, the 2v is what I care about. The plus 1's just along for the ride. 2v goes into 8v squared how many times? Negative 4v. So I have a minus 4v. Okay. So negative 4v times 2v gives me negative 8v squared. Negative 4v times 1 is negative 4v. And then again, I subtract. Negative 8v squared minus negative 8v squared is 0v squared. Negative 10v minus negative 4v is negative 6v. And then bring down the plus 5. How many times does 2v go into negative 6v? Negative 3 times. Negative 3 times 2v, negative 6v. Negative 3 times 1, minus 3. Subtract. Negative 6v minus negative 6v, no more v's. 5 minus negative 3 is 8. This is my remainder. That's my answer. V squared minus 4v minus 3 with a remainder of 8. Okay. Next one, n minus 3 into 5, n to the 5th minus 2n cubed minus n squared plus 2. What am I missing? N to the 4th. I don't have any n's to the 4th. I have to have an n to the 4th because when I do n into n to the 5th, I'm going to have n to the 4th. I have to have something to line it up with when I do my dividing just like I did with all of these powers. They're all lined up. I have to have an n to the fourth. Every power has to be represented. It isn't there, so what do? I have to rewrite the problem. And I have to put in 0 n to the fourth. If I had like n to the 10th plus 2, I would have to put in a 0 n to the 9th, a 0 n to the 8th, 0 and so on. Every power has to be represented. Yes, sir.
So don't you need an n too?
Oh, you're right. I do need an n on there. My bad. Thank you for catching that. I have to have a 0 n and then plus 2 here at the end. My bad. Thank you for catching that. And then we do the same thing. And it's nice when you have just n in the front, because it's easy when you don't have a 2 or a 3 or 4 or 5 in front of it. Okay? So n goes to n to the 5th, n to the 4th times, multiply times n to the 4th, n to the 5th minus 3n to the 4th, and then I subtract. N to the 5th minus n to the 5th is 0. 0 n to the 4th minus negative 3n to the 4th gives me positive 3n to the 4th. Watch your positives and negatives when you're doing your subtracting. Once again, an area that students often mess up in. Bring down my 2n cubed. N goes into 3n to the 4th. That's an easy one. 3n cubed times 3n cubed times n, 3n to the 4th, 3n cubed times negative 3 minus 9n cubed, subtract. 3 minus 3 gone, negative 2 minus negative 9 is positive 7n cubed. Bring down the minus n squared. N goes into 7n cubed. 7n squared times. Like I said, it's easy when it's just n or x or whatever. There's no number in front. 7n squared times n. 7n cubed. 7n times negative 3, negative 21n squared. Subtract. Negative n minus negative n squared minus negative 21n squared gives me positive 20n squared. And then bring down my 0n. Wash, rinse, repeat. N goes into 20n squared. 20n times, and I get 20n. 20 times negative 3 is negative 60n. Subtract, I get 60n. Bring down my 2. N goes into 60n. 60 times. 60 times n minus 3 is 60n minus 6 times 3 is 18. 180. Subtract 2 minus negative 180 is 182. So my final answer. N to the 4th plus 3n cubed plus 7n squared plus 20n plus 60 with the remainder of 182. Isn't that lovely? Isn't that love?
Have you ever used a spoiler?
Yes, I use it every year.
Yes.
Okay. Okay, so the first one, b goes into b cubed, b squared times, multiply by b squared, subtract, you get negative 3b squared. B goes into that, negative 3b times, negative 3b times b minus 1. Subtract, you get minus b, bring down the 3. Negative 1 times b minus 1 is negative b plus 1. Subtract, you get 2, so it's b squared minus 3b minus 1, remainder 2. Second one, also it's fairly easy when you just have a y in front. Y goes into y cubed, y squared times, multiply by y squared, subtract, you get 5y squared, so it's 5y times y. Gives me 5y squared plus 10y, subtract, you get minus 15y. Bring down the negative 6, negative 15 times y, multiply it, subtract, you get a remainder of negative 36. Y squared plus 5y minus 15. Questions? We'll finish this manana. You're right. My bad. Oh. So that would be minus 6. That would be minus 30, so it would actually be plus 30, which would give me a remainder of what? 24. So that's wrong, and that's 24. My bad. You were right. I was wrong.